All right, welcome back. Hononegah, Honors, Algebra 2. Today we're going to do section 4.6, the fundamental theorem of algebra. You've probably never realized this, but throughout your mathematical career, you've solved a variety of different equations. But the degree of those equations is actually the number of solutions there are. So again, looking at this very first one, notice it is x to the first, so it has a degree of 1, so there's going to be one answer. The next one is a quadratic, x squared, so there's going to be two answers. The next one's a cubic, therefore there'll be three answers. And the last one is also a cubic. Now, they wanted to point this out here, that notice that if you have the same answer twice, it still counts. So even though the -1 and -1 are both answers, it's the same answer, but they still counts twice. So again, the number of solutions in this case is 3. So that is the fundamental theorem of algebra. The corollary to the fundamental theorem of algebra also means that there's the nth degree polynomial has n zeros. So when I'm looking at this, how many solutions, I'm not asking you to actually solve this. I just want to know how many solutions does the equation x to the fourth minus 2x cubed plus 5x squared plus 12 equaling 0 have? Well, it has 4 solutions. Again, the degree tells me how many answers I should have. So as I go through this lesson today, and as I see different type of equations, I should always look at the degree. Basically, that's going to tell you how many answers do I need. So the next one has 3 solutions or 3 zeros. So now I want to actually find it. And again, from what we just talked about earlier, there's going to end up being 4 solutions when I'm done here, or 4 zeros when I'm done. Now, this is where I told you the graphing calculator is going to come into play. You do need to show your work and prove it algebraically. You can't just write down 4 answers here. So please make sure you understand that just because I know there's going to be 4 answers and just because the calculator is going to help me find those 4 answers doesn't mean that I don't have to show my work. So I'm going to flip over to a graphing calculator, and I already typed it in. So you may have to hit pause for a second. So, all right, hopefully you're back and you've typed it in. So now let's hit the graph button. And I'm going to notice that this is crossing once, twice, and just 2 times. So I only see 2. But I want to know where it's crossing the x-axis at. So I'm going to go to the table and see if I can see it there. And I have changed my table increments to go by 0.25. But I do notice down here at the bottom, there is one solution that I see. I see +1 as an option. So I'm going to go back, and I'm going to put +1 and see if that actually works algebraically. So now, pull the first number down, multiply and add, multiply and add, multiply and add, multiply and add. So yes, it worked. Got a remainder of 0. So now, I'm down to a new equation. I no longer am at x to the fourth anymore. I'm actually considered down to x to the third. Okay, so now I want to find another one. And I can use the same graph. So when I go back to my graphing calculator, I can use the same picture. And I noticed there was another one in the graph. It looked like +1, but it looked like over there at -2. So let's go check my table out and see if that's right. And again, I'm going by 0.25s, so that means I have to go further. And it is. Look, I can see it, even though I went too far. -2, 0. So I'm going to go back and prove it algebraically that -2, 0 is also a solution. So multiply, add, multiply, add, and multiply and add. So now I'm down to a quadratic. I don't want to actually use my graphing calculator anymore. I'm down to something that I can solve using the various methods I learned in chapter 3. So x squared plus 9 equaling 0. I would solve that by subtracting 9, taking the square root, and getting x to be plus or minus 3i. So again, not all solutions are rational. I have 2 solutions that are rational and 2 solutions that are imaginary, but I have 4 solutions to this particular graph. Next one, and again, I'm going to have to go back to my graphing calculator. So when I go to the graphing calculator, and I already typed it in for you, I'm going to hit the graph button again. And if you need to pause for a second before you, make sure you type that into your graphing calculator. I'm looking at this and I see it looks like it touches at -1. That means something. Remember, we talked about that a little bit. And then it looks like it's crossing. So I'm going to go to the table function and double check where it's touching and where it's crossing. All right, so remember, I'm trying to get 5 solutions, and -1 is an option. So I'm going to go and I'm going to prove this algebraically. So -1, I think, should be a solution. No, 1x to the 5th, no x to the 4th, 1x to the 3rd, -2, -12, -8. Don't forget the 0 because there isn't an x to the 4th. Bring the first one down. Multiply and add, multiply and add, multiply and add, multiply. Again, when I say multiply, you're taking the number as the divisor and the number at the bottom here and putting it in the next column. Multiply and add. So look, 0 is -1 is a solution because it came up with a remainder of 0. Now, I remember in the graph when I looked at it that -1 was a touch, not a cross. And anytime something touches, there's an even amount of zeros. So again, -1 was a touch. So when I do -1 again, it actually should be another 0. Let's see if that works. -8, +8. And it did. It worked twice. So now I'm looking for a third one here. Again, I'm going to keep going on this. I'm going to go back to my graphing calculator and see if I can find a third one. And so I'm just going to scroll here. Even though on the picture it looked like I could tell what it was, but I'm just going to scroll here, and it is 2, 0 is another one. So when I go back to my work here, I think 2 will also be. Bring the first one down, multiply and add, multiply and add, multiply and add. Again, now I am down to a quadratic. So I have 3 of the 5 solutions. I now need to find the last one. If I subtract 4 from both sides and take the square root, I get plus or minus 2i. So 3 of my answers are rational and 2 of my answers are imaginary. Next one. You will notice that now we have a cubic, so I know how many solutions I'm going to get. I'm going to have 3 answers. So I'm going to go to the graphing calculator again, and I'm going to see if I can find some of them. So when I go to the graphing calculator, and again, you're going to probably need to hit pause because ultimately I have typed it in already. So when you type this in, now you're going to hit graph. And so I hit graph and I'm looking for solutions and I see it's going to cross at one location, but it's not going to be very friendly. Again, I've changed my table to be by 0.25. And if you don't remember how to do that, go to second table set, which is the window button, and you'll notice it says change in table. That's the little triangle table. And so now my table is going by 0.25. So I'm going to go second graph and I'm looking and I see it. It's -0.5 or -0.5. So when I go to solve this, I see where it's going to be a 0. So I'm going to prove this. Remember, you must show your work. So -0.5 is what I think is a 0. So synthetic division. -0.5 times 2 is -1, and I add. -0.5 times -14 is +7, and I add. And -0.5 times 26 is -13, and I add. So now, I'm down to a quadratic that I want to solve. Well, this one isn't as nice as all the other ones that I've had, and it's not factorable. So I want to, and if it's not factorable, then I have other options, such as the quadratic formula. -b plus and minus the square root of b squared minus 4ac all over 2a. So now the hard part about this is always what's known as the discriminant. We've done this before. When we did quadratic formula, we did this. So I need to figure out what the discriminant's going to be. So -14 squared minus 4 times 2 times 26, which would be -12. Now, continuing, whoops, sorry about the 2 on the bottom. That should be a 4, 2 times 2. So now, continuing, I need to simplify the negative 12. So 14 plus and minus 2i square root of 3. And then because each of them is divisible by 2, I can actually reduce this particular fraction by taking a 2 out of all of them. Now, you can't just do like the first one in the 4, like the 14 and the 4. You'd have to do it to all 3 in order to reduce this. So again, there was one rational solution and two imaginary solutions, which made up our 3 solutions. Next thing we have to talk about is what's known as the conjugate. Just like before when we talked about irrational answers come in pairs, imaginary answers come in pairs. So if there's an a plus bi, then the conjugate must also be true where a minus bi is also solution. Now this goes back to something we have actually done previously, and this is challenging. Okay, they're going to give me some solutions and they're going to ask me to come up with the question. So they're telling me that x equals 5. And they're telling me that x equals 1 plus I. What they're not telling me is x must also equal 1 minus I, because if you have one imaginary answer, you must have a second imaginary answer. Remember, you're going to work this problem backwards. Instead of, now I have the solutions, I want the question. So x minus 5 equals 0. X minus 1 minus I equals 0, and x minus 1 plus I equals 0. So again, I'm turning these into the factors. So instead of actually taking the factors and solving them, I'm taking the factors now and foiling it back out. Suggestion, and it's not really even a suggestion, it's probably a you have to, do the imaginary parentheses first. So x times x would be x squared, negative x, positive xi. Negative 1x, positive 1, negative I. And the last one, negative ix, positive I, and this is the hard one, negative I squared. Now, I squared is negative 1, so it's negative 1. This would actually be a plus 1. Add all the like terms. And what you're going to find is some of these things are going to start canceling out. So a negative x and a negative x make a negative 2x. That's these two. A positive xi and a negative xi cancel each other out. A negative I and a positive I cancel each other out. And so then I'm left with just 1 plus 1, which is 2. Finishing now, I just have to FOIL these two out. So I get x cubed minus 2x squared plus 2x, negative 5x squared, positive 10x minus 10. So finish line now. Add the like ones together, and that would be the question that has those 3 as your solutions. So again, when you have 5 and 1 plus I and 1 minus I as your solutions, this would have to be the question in order to get those. Your homework assignment tonight is, oh, I'm sorry, one more. I apologize there. There's one more question. A tachometer measures the speed in revolutions per minute, or RPMs. Some of your vehicles might have an RPM, at which an engine shaft rotates. For a certain boat, the speed, x, in hundreds of RPMs of the engine shaft, and the speed, s, in miles per hour of the boat are modeled by s of x equals 0.0057x to the third minus 0.225x squared plus 3.62x minus 11. What is the tachometer reading when the boat travels 25 miles per hour? So now the speed in RPMs of the engine is the x, and the s is how fast the boat is actually going. So this is actually the s, or the s of x. So 25 equals 0.00547x cubed minus 0.225x squared plus 3.62x minus 11. Now I want this to equal 0. So I'm going to subtract 25. So I'm going to have the exact same function plus 3.62x minus 36. So here's the function I want to try to solve. And I'm going to use my graphing calculator to do this, and I'm going to make it do all the work. So I'm going to go over to my graphing calculator right now. And notice that I've already typed this in. So many of you are going to need to hit pause for a second. All right, welcome back. So hopefully you've had that typed into your graphing calculator. I'm going to hit graph just to look at it, but it's really not going to be too beneficial for me, to be honest. And you'll notice that I don't actually see anything in the picture. So let's go to the window and see if there's any, if I can make this window bigger if it does anything. So I'm going to go like negative 100 to positive 100. And see if that does anything for me. Like all of a sudden I start seeing something. And I do. Look, I see where it's crossing the x-axis right there. So there's a location, and I want to know what that location is. So I'm going to hit second and trace, and I want a 0. So number 2, that one. It's always going to ask you for left bound and right bound, and I need to make sure that we understand what left bound and right bound, meaning if I'm to the left of a particular area and to the right of a particular area, it's going to give me the answer in between. So get to where you can see your cursor here. So I'm going to arrow to the right so I can actually see the cursor, and it's coming. There it is. So I'm going to hit enter. So now there's one spot, and now I'm going to arrow to the right till I'm above that spot. So again, it wants to give me the 0 that's in between, and I never want to guess. So hit enter. So the 0 is at 25.24. So going back to my, just to make sure I write down my answer, 25.24 RPMs, okay, would get you, and now this is in hundreds, RPMs would get you a speed of about 25 miles per hour. Now let's see if I'm correct. So your homework assignment is out of the book on page 202. If you have any questions, please make sure you talk to your teacher, and good luck.